So hello, my name is Erki Aas, and today we are gonna talk about cloud native development, how to do cloud native development by the example of Node.js. Initially, we planned to talk about networking in Kubernetes, but unfortunately, Rainer got sick, and this will be postponed to next week or week after that. The goal of this series is to talk about cloud native topics, security regarding that, and to get more people join our hackerspace and generally upskill people working in the IT market, as the cloud is the next big thing or where everything is moving. And therefore today we're gonna get to know how cloud native concepts play with development, what are the upsides and downsides, what to keep in mind regarding that. We're gonna remove some mental blocks such as what about local development and etc. We're gonna learn a new tool and put a hands on it, and then after that we're gonna discuss it a bit and mingle over pizzas. So why do we want to develop our applications in Kubernetes already in the cloud, not do it the old way where we just do something on our local host and on our workstation, push it up to Git, and then let the DevOps team to do and deploy it and not give a F anymore. So if you, in order to develop the application to very similar environment that it would run in production, therefore if your application has some system level dependencies, or okay, you are using containers to develop it, but you're using containers to deploy it, then the container image, base image, or whatever you do regarding that should be the same already in development. Who creates the application deploys it effectively. And also it's with the same thing is with Kubernetes manifests. This in the production would define a lot of things, such as what ports is your application exposing, how many instances, okay, not that much, but how many instances does it run, and also what ports should be open and so on. And if you would let it, if you as a developer don't do it, then DevOps would have to do it, and that would create a lot of forth and back communication. I'd say needless communication, because you as the developer know your application or a microservice the most better, and it would also give you even better idea why something fails in the cloud. And also other reason is to quickly set up the development environment. Of course, nowadays Docker Compose is also quite popular. Nobody tells you, I guess, to install a lot of local applications on your host. I mean, runtimes such as Java or Node.js or whatever. But still, you would need to keep track a lot of things, what you have installed and what Docker Compose is doing, what in where. But in case of Skaffold, which we're gonna talk about today, all you need is this single repo and this Kubernetes specific tools, and you could just run it and not care what is on your host or not. And also you want to develop your microservice or application already in the cloud, in Kubernetes, so you could get a good understanding how it links with other services. the modern way of creating applications or services is that they all they contain a lot of microservices, and one microservice might communicate with only one another microservice or a lot of them. It would use some kind of database. It's totally stateless, so to say. Only the databases are stateful. The application itself should be designed to run in multiple instances and so on. And if you would start to create all of this supporting infrastructure or supporting service mesh on your local host, then you would do a lot of it would take a lot of work, and you wouldn't indefinitely. It doesn't guarantee it that you get the things right, like on a database on your local host running, I don't know, one instance of MySQL, for example, versus a lot of a highly available MySQL in AWS are not the same things. And also, if you deploy it, if you develop it in the cloud or your Kubernetes cluster, it would also enable you to use the features of the Kubernetes cluster, such as manage databases using operators. It was topic last week, how to do persistence in there, how to in perfect world order a database and it's just there. Also how to create public web addresses and endpoints using ingress definitions. So classically, if you would run something on your local host, you would need to use this ngrok or some other similar service to make it work. If you want to access it from other actually public web, in case you're developing something which receives webhooks, for example, it's all much neater and more standardized. If you would already be already developing on Kubernetes. And also the last thing to point out is this scale. If you would run something on your local host, you probably are not running 3 instances at the same time and not also load balancing between them. It's possible to do it, but if your little microservice is going to be deployed on scale at the cloud, in the cloud, then you have to keep in mind that you have to develop the application accordingly, and you don't want to find out all of these race conditions and other related other related stuff when something crashes in production, but you could already test it all out while developing. And it also greatly connects to the 12-factor concept of developing. I didn't know the link was also in the previous time. The 12 factors how a modern microservice-oriented application should be created, and this scaffold or the thing we're gonna see today really connects or gets intact with that. If I have introduced the idea of developing something in the cloud, I have received a lot of questions, or not a lot, but fairly. There has been a question that what about offline development? What if I like to write my code while being on a train to Tartu or whatever, when there is no internet connectivity? Well, it is resolvable. You could use Minikube to install your own little Kubernetes cluster on your laptop. It of course is a little bit more heavier than Docker Compose, but the concept is the same. You get a little environment for some development purposes, and that should work. It should be quite out-of-box experience. Of course, doing that, you have to keep in mind how your little environment fits to the bigger picture. Legacy applications were big monoliths with a lot of like one big code base, or I mean one big backend to say so, one big front end maybe, and one big like database behind it. So to get all that on your local host is quite madness. I mean depends on your application, but no, some databases are small, some databases are hundreds of gigabytes. It all like depends. But also like I'd say that an offline development or development on workstation also like hooks well with the concept of microservices and cloud native, because in this cloud native way you don't have, or you preferably don't have one big databases, but more like distributed data sets between between like microservices and their databases. So your data is like already distributed. And then if you would like to develop a part of the big application or service, one microservice with some limited data set, which is, let's say, I don't know, a few hundred or few gigabytes, then a few hundred megabytes or a few gigabytes, no more. No, this is, yeah. Then it's more, a lot more like doable to get that data set on your laptop and do it offline. Then you get a big monolith and enable developing that on your laptop. If you're big monolith, if you need to work or test something with large data sets, then it's just, I don't know. If you like to have few hundred gigabyte databases on your laptop, then go for it. But and as I mentioned, today we're gonna do it all in this example of Node.js, but the concepts and the tools are perfectly applicable to other programming languages. No, of course, they all have their caveats, either like are they compiled or not compiled, or and so on and so on. But the main concept behind them, I'd say, is the same. You just like the compiled versus non-compiled thing is the development speed. I mean the feedback loops time. In case of non-compiled languages, you just copy something to the container, and it would already be new in the next request. In case of compiled, of course, you have to compile them, but in general picture, it all works the same. And for that, we are gonna use Skaffold. Skaffold is a tool created by Google, which will build the container using a provided Docker file or some other instructions. It also supports Maven or some other custom builders. You could like do whatever what you want with it, but no, we are going to use Docker files to create container images for cloud, or I mean Kubernetes. Then it would manage the Kubernetes deployment using a provided manifest or Helm chart or KPT templates, whatever you prefer. It would watch changes in files, and when needed, either rebuild the container or copy the changed files into the container running in Kubernetes. That is, I'd say, the biggest like good thing about this tool is that I think a lot of people have seen like CI continuous integration tools, continuous integration setups where you push something to a Git repo, and then a builder, or the pipeline goes and deploys it, creates it and deploys it. But doing changes and seeing how they work in that case takes a lot of time. Of course, few minutes is like debatable how long is it or is it not, but I like to see my changes right now, and that's why this Skaffold, that's why I really like it. And also Skaffold helps you to manage integration with your workstation with development such as port forwarding, which is useful for not for communicating with your microservice directly from your workstation, either like doing HTTP requests to it or using debugging or like other development tools. So here's a schematic describing what is this scaffold and what it does. It effectively, it's watching your files. Who has developed JavaScript, either Node.js or front end, rather front end in Node, then you may have heard of npm run div, which usually like watches the files, and if you like change a file, it will refresh the browser. Well, Skaffold is effectively doing the same, but not just updating the browser. It will either totally restart the process, or it will just copy it to the running container. So, and also it enables a lot of other like deployment specific tasks or tricks. It can tag your containers, or I mean artifacts, which are the container images with some commit IDs or hashes, or it enables really like large and complicated use cases, I'd say. So in order to use this tool, you would need regular kubectl, of course, to manage Kubernetes. Then you need the scaffold itself, and also if you prefer, then Docker Engine. Docker Engine enables that it builds the container on your own machine. It's usually a lot faster than doing it in Kaniko. Of course, it also depends. Sometimes Kaniko is faster or whatever. But in my experience, using it in your local host is a lot like faster. Then a Docker file, which would do whatever your application needs to do, or in the essence how it in example how it would actually be used in production. So it would not only install the runtime and dependencies, but also will use the code itself. It's the like it should be the final. It should create the final production image effectively, how it would actually be deployed. So you would also need Kubernetes manifests, of course, to define how this microservice or application is like deployed in Kubernetes. Then comes the scaffold configuration file, which manages all of this stuff. It combines the building the container and the deploying part. It describes what files will be copied to the running container, or which, or in other case, the container, or I mean, container image will be totally rebuilt. For example, when you can do hot reload or whatever, then it should like start the then you do it in the container can handle it itself. When it's doing some, let's say you change Node version or whatever in Node version in Docker file, then of course you would have to rebuild the container to get the desired effect. And it also is possible to do port forwarding, which we will talk a little bit later. You would also want the Docker ignore file, because if you like IDE creates or messes with some files, or you just add a line to readme file, you don't want to rebuild all of the full container. You just want your actual code, functional code in the container. And of course you need a Kubernetes cluster, and you need an image registry in case if it's a remote cluster. In case of Minikube, it is automatically integrated with your local or your workstation's Docker engine. Then you don't need any other services. But in case of regular Kubernetes clusters, you would also need a registry in the cluster, or use some other registry such as GitHubs or GitLabs or etc. I guess the most efficient is to actually get the hands on, and then while we are on it, I will talk about some stuff in detail here and there. So you most possibly have already visited the dashboard and used it to get the sandbox and run something on it. Now go back there, and there you should also see developing tab, which contains some instructions. First, we need to log into Harbor, I guess, because it takes a little bit time. Harbor is our local image registry where all of you can push images so that our cluster can get them. Then you would also install Skaffold and then clone the repository, the example repository where we can work with. Yes.
I found a fix why it's not starting. Kas on server.js ja app.js vist?
Kuskil seal oli mingi bug'i või? Okei. Ja. Fair. Ma ei tea, kas ma muutsin selle nagu siit. Okei. Ja. Last minute improvements. Hotfix. It all worked nicely, but then I came to an understanding that there may be people with modern MacBooks. And in case of modern MacBooks, which use ARM processor, things get a little bit funky, because when you build a container on your workstation and push it to the registry, and all of the Kubernetes is regular x86 machines, then they would not know anything what to do with the ARM images. So I found a quick solution to that.
So how does one log into Docker into the hardware?
Maybe you can demo the...
Yeah, great question. We should go to harbor.codemovers.eu. It will prompt you to login. You will just log in into the Harbor. Then go to your project, which you're administrator of, and then you can find a tab called Robot Accounts. Here you can create new robot accounts. These are already created by the operator. Yeah, click here. Put some kind of name, let's say lab, and also you can, I guess, set expiration time to never, and just add it. Now you got a username and a password, and you can use them to log into. You can use them to Docker login to harbor.codemovers.eu. I have already logged in. That's so it will not log in again and say login succeeded. But in case of you have, can I log out here? I wonder. I guess so. So it will ask a username. The username is this here, and the secret is the password. And that's why did not work. I don't know, maybe I misclicked something. And it should say login succeeded. Nice.
There's one caveat.
Yeah.
Like the moment you log into Harbor, it will take a couple of minutes for the automation to give you the access controls to your project. So your project named after you should become visible eventually.
Yes. Because of that, yeah. I don't know if you heard it totally, but if you don't see your project name, which should be your username here, then just wait a few minutes and it should appear there automatically, or after a refresh. Okay, the second step compared to previous is to get Skaffold. Just go to Skaffold dev and click on CLI and install it using this command here. You can like always reinstall it, I guess. And it should be there. Okay. So I guess we could look at the project now and kind of explain and go through what is happening here. So this is our like boilerplate application, which you can find in GitHub and clone it to your own PC. Now, I guess we could start from the Skaffold manifest, which like which leads or controls our full development, the full mechanism. Here we have like the name of the application. Yeah, the repo is codemowers, github.com/codemowers/hello-node.js. I don't know if I can you maybe put it to chat or something? Great. So yeah, here we define a name. Here we define the Kubernetes manifest. We'll look at it later. Then you could fine-tune how it's deployed using kubectl, but we're not gonna do it. Then comes the crucial part, which is the build and artifacts section. So here we define an image. Image is a Docker image, a regular Docker image, which you can run in Kubernetes or Docker or so on. Then we have different options. So at this example, currently we can use Kaniko to build this container in the cloud. That means that you would not have to have the Docker engine on your workstation, and I believe you don't also need the access to Harbor or any image registry. This is useful in cases you don't want to compile or make it on your laptop, and also you don't have any registries available. But it, like I mentioned earlier, it's slower. But still, it should make a good start. So now let's see how to use Skaffold effectively, let's go to your dashboard, and there from sandboxes, and find your sandbox here. You could find tab called developing, and here is a pre-made command for this for your custom for your user and namespace. If we look at it, we see that we defined an Kubernetes context. It is about your Kubernetes configuration. It will also set the default repository or image repository to your Harbor project, which you should see by now. That helps us with image names, so you don't have to hard code your username to the manifests and configuration files, and it will also define the Kubernetes namespace where all of that runs. So if we do it right now and just run it, it should start looking at the images, or no, it would effectively start by running Docker build, which effectively uses the Docker file to build an image, and it's gonna do it in the cloud using Kaniko. So you don't, like I said, you don't need to use Docker. You have Docker on your own machine, but it's slower. So let run a bit. Let's go see our Docker file, I guess. So this is a regular. I mean, that kind of Docker file for Node.js applications developed in Kubernetes. You usually use this one or something really similar with it. I'm gonna use the official Node image, and I'm going to define it as the development stage. I'm going to make sure that /app is the working directory, just in case it is the default, but I don't want to take any chances. So, and I start by copying the package files to the working directory. Package files contain all of the dependencies my application uses. So, and as the next step, I will install those dependencies, and then I will also copy all of the code files into the working directory. So if I would change some code file, but the dependencies are not changed, then it should not rebuild the container. You can fine tune it. This is kind of trivial because I don't I have the app, or I mean I have a single JavaScript file and it's in the repository root. For bigger projects, you would create a separate directory called source and put all of the actual code in there. And then if you have and also it would not copy actually everything to the container, but only the stuff it's not filtered by Docker ignore. It gets rather annoying if you change like I said, some trivial files like readmes or whatever, or editor files, and then it will trigger the rebuilding of the container. You don't want that. And yeah, of course, if you would have a separate folder, you would put like a source and everything from it. To actually, you can define the directory where this or the context where this Docker file is executed. Not only here using like source / but also you can use Skaffold's configuration to say that it should be something like context, yes, and this could be like source, for example, and then sorry. No, single line. In that case, you would still just use dot here, but the Docker file would effectively be like it's in the source file, or whatever, in the source directory. So, anyways, now I have everything I need to run the development server. which we will look at soon, and why it's and now if I have in Skaffold, I have set that the target or Docker file stage equals to dev or development. So it will effectively run to this point and just do that. In production, I actually go further. I use the same progress, but I will rerun the dependency installer. If I do that, then npm or also yarn would remove the development dependencies to keep the container image smaller and so on. And also at the second point, I would not use npm to run the server in production, but directly Node. That's because when you do anything with npm, it wants to write something to your home directory. I don't know, for caching purposes and to keep a history or whatever. But frequently in production, the containers are actually prohibited to write anything to their file system. You can do anything, and if you try to npm run start in production, then you would just crash it. So that's why we will do just that, and no errors should occur. Of course, if your application tries to write something, then it will also fail. And going back to the development part. Here is my package JSON. I don't know how familiar you are with Node.js or JavaScript in general, but here I have just defined a single entry pointer application. Of course, in case of big application, you would have many files. And for developing, there is a single dev dependency, which is nodemon. And for developing, I will run the nodemon with those parameters. So what I do here is I will run application.js. I will enable inspecting, which is the debugging endpoint. I will talk that in a bit, and I will trigger reloading the application, not the full container, the full container. And if restarting goes to Kubernetes, then it will take time, because killing pod and restarting pod, it's one big Kubernetes mesh, and it's gonna be a little bit sloppy there, I guess, or to get the feedback or whatever. But nodemon wouldn't exit the process; it will just internally restart the node, and for Kubernetes it seems it's still running. And I'm gonna restart it if some changes happen in either JavaScript or HTML or image files. It's all like definable, it's just some default I found. And that's about it. Now let's briefly see the deployment file. This is also really basic Kubernetes manifest. I'm gonna name my deployment hello Node.js, create single replica, pull it down, use the container we have now created to run it. These are some sane defaults, or automatic aliases. And here comes the important part, that our container will expose a port 3000, which is kind of like JavaScript default for running. Of course, you can reconfigure it to use some other port, 80 or 9000 and whatever you like. And this name is also actually not correct here, but you can have multiple ports doing like one would be the main port for actual communication or actual service, and then have an extra port for Prometheus endpoint, for example. We would need to wrap the deployment in a service. And then from ingress we can use an ingress definition to access or give the access to this service from the outside world. Just we will define a traffic ingress definition. Please, you can use the deployment file as is, but you have to change the host to whatever is your or I mean, this part here, whatever is your slug or the sandbox name. In case of me, my sandbox name is JB7i. You can just use that, not use that, but use your own sandbox name here. And you can label everything as is. So here, yeah, we have defined that we want to access the service from this URL. We want to access the service hello Node.js on port 3000, and it should just work. So yeah, here I changed the Skaffold file. Let's try to run it again with Kaniko. Also, one point with Kaniko is the problem I just today discovered or came on. In case you are using modern MacBooks which use ARM architecture, or actually any other computer which is ARM based, such as Raspberry Pi or some modern other stuff, then in case of using your own Docker engine on your laptop or whatever device, it would build it on ARM architecture. And now you upload the image to the registry, but if your Kubernetes cluster is x86 based, then it would not get the access to, or the images are not able to run there. So this is a thing to keep in mind on, or a thing to consider. Of course, some clusters already have also ARM workers, and it's not a big deal. Also, you can create a workaround by creating a custom builder in Skaffold, which would wrap the Docker CLI into it and tell the Docker to use buildx, which uses some kind of emulation layer. So you're able to build for x86 on ARM or vice versa or whatever, but it's more slower and it has more overhead. Maybe one day Skaffold will have configuration option straight in this YAML file that please build for target using Docker buildx, and it would be simpler. Skaffold is really like developing or really quickly developing. When I stumbled across it like half a year ago or even more, it was still like version 1 something, but now it's 2.0. Alpha recently was alpha, and now it is really popular and growing every day. And yeah, now yeah. So if you take this Skaffold YAML as is from the repository and run it using the command you found here, it should work. And you see here that the image was built, or no, it works just as regular Docker image, just that you want the SHA checksums will be calculated, and it will just rebuild whatever is necessary, not rebuild always. And then it will deploy it in the Kubernetes cluster. And IS port forwarding, we'll talk about this soon. And you should see this kind of state that server is running on this URL. So technically, if you open it, you should be able to see it on your. If you have 4 zeros, then it will be equalized to localhost. And how this works is that in Skaffold file end, we have defined port forwarding. So, here we can take a resource, let's say deployment or service, and our hello Node.js, and forward it from the container to our localhost. And I also have another forwarding here. I will talk about that soon. And so you would not have to use the ingress at all if you don't want to, or any yeah. And now this container runs in the Kubernetes cluster. It's accessible for other services running in the cluster, but it's also just proxy to your localhost. You can just use Postman or whatever client you want to interact with this endpoint. And because it's using Node.js to run, you can just edit the code. Edit the code here and save it, and you will see that and you can see that the Skaffold picks the change. Okay, yeah, right. I have because we were using now they I changed the Skaffold file at the last second. Sorry about that. Anyways, currently it's running in the production mode. It went straight to the end of the Docker file. It's just doing running Node app.js, so it will not pick any automatic updates. However, if we add Docker target dev, target is the image.
Can you make the font bigger?
Yeah, sure. Remove the comments from Docker and target lines, but this is conflicting with the in cluster building, I believe. Yeah. Well, so we have to disable the Kaniko or building in cluster, and now we would actually use our own Docker engine on my local-host to build it. And this, as you can see, is a lot faster. Now, of course, I have already downloaded the base image, and this is reasonably fast laptop. It all depends. But it's now doing regular Docker compose and regular push to the registry from my machine to the harbor.codemowers.eu. And the next step is the same. It will, now the image is up, it will just run kubectl apply deployment YAML effectively. Sorry. And now you can see that it was started with the development command. So now we have the Node.js controlling the process, telling us that is watching, telling that if the debugger is enabled, and so on. And now the localhost port 3000. Yeah, you can just do that. Sorry. It's still running, but now we can just change the code. It will quickly sync and restart the process, and we have the application refreshed. Now the next step is that also in deployment we define the ingress, so we can access our service publicly if we wish to, to test webhooks or demo your application to other persons, and you should be able to access it from public web, depending on whatever is your host name you defined in the rules. And I guess the last step, which I have talked a lot, is the debugger. Debugging is built into Node.js, and also JavaScript generally. Okay, not generally, but in Node.js and also Chromium and a lot of JavaScript-based things support it. How does it work? Is it will expose a separate port. It will listen to separate port which you can initiate the WebSocket connection with, and this WebSocket connection uses some custom protocol let me see, I also found the, okay, whatever. The custom protocol is used to like define entry points, or I mean breakpoints, so it will stop executing and give you the metadata. A lot of like dev tools dev tools and programs support this. Chrome, it's built into Chrome. Usually popular front-end frameworks such as React and Vue have some kind of Chrome extensions to debug it. I have no idea if we can just try it also in Chrome. And you also have VS Code supporting it, Visual Studio, JetBrains IDE, which I'm using, PHP Storm, also WebStorm, and so on, and also some other stuff. So I don't know. Let's see whether we can debug it with Chrome. Yeah, I think it automatically detects that it's running. I don't know if it is an extension installed on my PC or not, or in Chrome or not, but it just kind of worked out of the box. And here we can see actually our container running, because it is the same thing. I guess we can like console log. If anyone is actually doing it at the same time, can maybe validate what I just said. If you do console log hey here, then from Skaffold we see that it actually is the same process. And okay, what else we can do here? Well, it can profile it. Okay, yeah, you can do a lot of internal and that kind of stuff. I guess I'm not really familiar with Chrome's that kind of debugging, to be honest. So I'm using PHP Storm or WebStorm myself. Usually when I'm developing, of course, it's a paid and powerful IDE and very heavy. A lot of people like it because it's so heavy, but I really find it really intuitive and powerful. And here, in case of IntelliJ or JetBrains IDE, you can create a new configuration and its type of attached to Node.js or Chrome. You will just leave it to defaults. In the Skaffold configuration file, you can see that I didn't change the port. It's all 92.29. So you can just create a new configuration, give it some name. You leave everything default, and there you have it. And you can start to run it. And now you have the same thing you saw in Chrome. Let me see if I can make it bigger. I'm afraid not. The same thing as in Chrome, but now you can add entry points to your code. So I added this here, and now when my code runs, let's say in case something makes a request to it, then my IDE jumps up and I see everything, which is status of all of the variables and everything you need to debug it. So you effectively have all of the tools. Not all of, most of the necessities that you would usually on your local host, like the same things applies, that you can debug it, your code, you can access it directly. You don't have to like deploy it because it's already deployed. And yeah, I believe this is like it. I guess I would also mention that there are two more like alternatives called DevSpace SH and tilt.dev. I haven't gotten deep into them because I have been mastering Skaffold, but these are like analogous, not by third parties. they are, people say on the internet that they might be more difficult to set up or might be not. They have, one of them has an GUI, if you like to see how it's working by some graphical interface on your localhost. Maybe more bulky by that way, but yeah, your mileage may vary. I guess all of the three, Skaffold, DevSpace, and Tilt are like powerful tools, and yeah, why not? So yeah, thank you for listening, and I would answer some questions or show something if anyone likes to. Do we have any online questions?
Do you write any kind of integration test?
Yes, I do.
Maybe you could elaborate how.
Integration tests, I mean, yeah, yes. It depends where you want to run your integration tests. Usual place where you run them is pipeline, but in case of Skaffold, you can define. Let's go into Skaffold documentation. You can define run profiles. So you would do something like something like this, and okay, I will maybe increase the size. Give me a second. Well, anyways, yeah, you can define this is like Skaffold run profile 1 or Skaffold run profile 2. You will create different definitions for your testing and development loop, I guess. Now, of course, you could write deploy here and deploy it using Skaffold, but it's kind of unholy. But you can do it. But it's kind of like not the way. But yeah, I understand if you're like developing and don't want to wait for the pipeline to give your unit test results, you can just create some configuration here, and because yeah.
Maybe one thing that's worth mentioning is that you can run the Skaffold command directly in terminal as well, but you don't need to run it from IDE.
Of course, yeah. Like this is just on terminal integrated in the IDE, but it doesn't really matter where you do it. You will just take the command and go to your. Let me see. I have to stop it here and just run it. Yeah. It's a regular terminal application, and it listens to Control-C, and you can you should gracefully shut it down, because otherwise you will leave the deployment running in the Kubernetes. Of course, you can use that to keep it running, but it's not this is not the way. But the good thing is that if it should crash or your internet connectivity should get lost, Skaffold will keep connection up with Kubernetes. I don't know if it's probably it's not doing anything, some web socket magic. No, of course with port forwarding it is, but my point is that if everything crashes, it will usually figure out what was left there previously, and it will tear it all down and also put it all up again. It will guarantee the state of the Kubernetes manifest to you.
So running kill-9 is fine.
Yeah, I guess.
Let's see.
Let's see. I don't know what happens. Okay, Skaffold is running. We have this running on our local host.
It was scheduled on another host. It was worker 1 before, now it's worker 4.
Fancy stuff. It is cloud native. It's not running on my PC laptop. Oh God. That's great timing. And okay, it killed the port forwarding because that was controlled by itself. But in Kubernetes, it probably is still up because Kubernetes didn't know it had to shut it down. And then now when we restart it, it will. Let's see what it does. It usually manage the image first, and yeah, it starts to deploy it, and Kubernetes told it that it's unchanged and it's already up. Or okay, it's doing rollout still. Interesting. Okay, yeah, it just starts working again. So yeah, I have used Skaffold so far to mostly to develop our log mower. I don't know, you have maybe visited log.codemowers.eu, and it was just great for that because we had Lauri and Lauri creating the collecting part where we use Python to get the logs from the workers and write it to Mongo. And I didn't need to know anything about it, only that I have MongoDB endpoint somewhere in the cluster, and I can just use Skaffold to start developing, put the Mongo URL into my application, and it's everything's there. We could just simultaneously try ideas or use different Mongo instances or whatever. And yeah, also in the log mower consists of front end and back end. The back end is Node.js, front end is Vue. In production, I don't use any kind of server-side rendering. It's just compile Vue and just Nginx is serving it. But in order to develop it, I just had to open 2 scaffolds running simultaneously. Of course, with different directories and code bases, but I can have many scaffolds running at the same time as long as they don't, of course, the port forwarding collides or whatever. So yeah, like regular developing, you will start up our projects and do it all together.
But you just have lots of machines.
Yeah, and also I'd say, which is one nice thing with this regular web developing is that I don't have CORS problems or cross-site origin yada, because I can deploy using the ingress. I can deploy my front end at the base path and just use API as the backend part, and or backend put the backend to the API, and the traffic load balancer will manage that for me. So in the eyes of my browser, everything is totally legit. The certificate is on, and then I don't have to think a second about CORS problems. So that's really, really nice.
Looks like I managed to kill mine by doing the kill test.
What exactly did stop? The container too?
Basically, it says that everything is running, but I can't access it.
What? Well.
I also managed to change the files between the restart and with the container image again.
Yeah.
So I think it tried to do 2 deployments with different images.
Oh.
So now there might be some.
Why did you change the file in the between?
Because I played around with the automatic reloads.
Okay, fair. That's a corner case, and I'm not a Skaffold developer. I mean, yeah, but if you now shut down the Skaffold, it should clean everything up, right?
I'm gonna try third time, maybe this time.
Okay.
Enable streaming.
Yeah. I mean, this is the future. This is a lot better than Elastic. Yeah, yeah, Ikebana. Okay, great. You found a corner case, I guess.
Yeah, you have to restart it 3 times.
I don't know. Restarting once usually works for me. Okay. Anyone else did try it?
Try what?
I see
Don't
4 people.
stop it.
Crashing it or
Well, I stopped
okay, not
mine,
crashing.
but,
No, just get it up working. You don't have to get violent with it like
4
Arti did.
people have it up and running.
Okay.
When I stopped it, the deployment in Kubernetes didn't stop.
Really?
Yeah,
How did you stop it?
just Ctrl+Z.
And it didn't.
Still running. Yes.
Okay, that's strange.
Maybe it's expected behavior.
Because
Did you change the address in the manifest, Kubernetes manifest?
like
Yeah.
you should see here. Okay, sorry. When I close it, it should say cleaning up, and it will delete all of the 3 things defined in the
Just
manifest.
once, Control-C, not twice.
And also, I guess if you would,
Second time it doesn't shoot.
I think on second attempt it will just kill itself or something.
I guess if you would use control,
Yeah, I have
yeah,
cleaning up, but
The deployment YAML file has the host name in the line
Yeah.
54. You probably have to customize it, otherwise you will connect to Erki's.
yeah.
I changed it to mine.
Okay, and it's still up.
Yeah.
Huh.
You can even access it.
I guess it's another corner case.
There's a bunch of corner cases. I
Maybe-
also
maybe
found the
it's-
bug.
Not corner case.
Like one of the bugs that I reported was that when you deal purely with remote building and remote deployment with Kaniko, it still does something with local Docker. Like you need to have Docker installed. So I reported the bug and they fixed it, but I don't know when it will be publicly available.
Also,
It worked for me, so
Maybe they already released the fix for
probably
this.
it's up to date. Because I didn't have Docker permissions,
okay.
or I didn't install it, so
So
worked.
Did you install Skaffold today?
Yes,
Okay.
and
I guess.
Docker also.
Okay.
Maybe there was no release.
Mine is quite old.
Okay. Maybe we should update stuff.
No,
No.
it works. I don't touch it.
This stuff is so rapidly changing that
Yeah.
It is. It really is. Yeah. Well, also, I managed what I did. I killed it with Control-C, Z, and now it also is kind of like doesn't know what it's doing. I guess. I have also seen it earlier that it will show something double. It's something to do with Kubernetes scaling and this kind of stuff. But usually I haven't. No, it shows. It seems funky, but in my experience, it works fine. Yeah, like your mileage may vary. I mean, this is cloud native. You have like a lot of. No, not cases. You have a lot of instances working. You have to handle the parallelism and so on. This is by design. Okay.
What was this application Lens that you just showed?
Lens is an IDE for Kubernetes. You can
it was in the Hello Kubernetes workshop
Okay.
in the previous ones.
Yeah, I would show it, but I just recently reconfigured my code movers. It should work actually. Let's see. I just recently reconfigured my Kubernetes config, and it has problems with it.
Yeah, that's
Okay, yeah, that's right.
Hello
Yeah.
Kubernetes workshop video. This is demonstrated in that.
Yeah, I will check it out. Thanks.
But I guess maybe to wrap up today, maybe we can quickly show drone, like the one that runs on Kspace.
Yeah, I guess so.
That I don't have it deployed for the code movers cluster yet, but later I will have like another demo about the drone, how you can now actually build the production images.
In case of drone, okay, I will quickly show another project. I will show the good event, the log movers backend. I have just added a drone file which will load a template. This template is the Docker template is just provided by automatically put into it. It's managed by Lauri, or I mean the drone part. of course you could customize it. And then what happens, and also keep it in mind that the Docker file is effectively identical to the one I just used in the demo. Drone doesn't know anything about the dev step. It will go just straight to the end and everything works. Now, yeah, this is the drone. It is actually not controlled by the Git or something like that. I think it uses webhooks. Yeah, Git makes a webhook to the drone after you have configured the repository, and then the drone will go and see the repository and just download it and build it. I guess Lauri could comment why it's better than, I don't know, using GitLab for custom.
Well, that's another story. But the point was that you don't use Skaffold to build production.
Yeah,
images.
exactly.
You use something else.
Yeah.
Either GitLab runner or GitHub Actions, or if you self-host, then you would use drone.
Mm-hmm.
But I guess I will do a whole presentation about this at some point later.
Yeah.
So, any more questions on YouTube? No. I guess we can go grab the pizzas and then continue mingling, and if somebody wants to get a Skaffold installed, we can help.
Mm-hmm.
Yeah.
Sounds good.